So I want to apologize for the sound today, having technical issues. So we're going over the characteristics of graphs of polynomial functions today. So the first thing I want to do is go through this graph with you guys so we can discuss the various characteristics. So hopefully you can see zeros, which are also x-intercepts. Here is one of them, and that is at 1, 2, -3, right? So we've got a 0 at -3. Then we got another one at 0. Then we've got another one at 2, and another one at 5, and an additional one at 7. Okay, those are all the zeros of our function, which again can also be called roots, or x-intercepts, or solutions. So then we have some minimums, and we have some maximums, okay? So our minimums are going to be our low points on our graph. So this is one of our minimums here. And we have to write this with an x and a y value. So when we talk about our minimum, it's going to be that 0.923. That's our x value of the minimum, of this minimum. And then negative 1.932. And then we have another one, if you notice, right here. Okay? These are minimums. So that means the low point of the graph, right? So on this, then, we're also going to write 6. I'm going to put 238, and that's our x value of it, and then negative 4.608. Can't fit it there, y'all. I wrote too big. So there, I went and fixed it. And again, apologize for the sound, y'all. So now we're going to talk about maximums, okay? So our maximums are going to be our high points of the graph. So our maximums, we've got one here, and we've got one here, right? So once again, we're going to write these as ordered pairs. So this maximum on the left is negative 2.003 and 10.08. And then we've got another one, if you notice right here, and this one's going to be 3.642, comma, 3.623. To talk about the degree of the polynomial. Okay, there's a couple ways we can determine this. First of all, we can look at the zeros of the function. There's 1, 2, 3, 4, 5. So that means that it is potentially a fifth degree polynomial. But we can also talk about the number of times this turns. Okay, so we've got 1, 2, 3, 4, and we always add 1 to it, so that would be 5. So that's the other way that we can determine the number of degrees. So this is a fifth degree polynomial, okay? So our leading coefficient, this ultimately will determine, we're going to talk about this more in a minute. Basically, if the graph starts down and ends up, and it's an odd degree, and this is, right? So that would mean the leading coefficient would be negative, okay? So I'm just going to put negative here, okay? We're going to talk about that more in just a second as well. Obviously, it's odd, right, because it was fifth degree. Okay, so that's what tells us that it starts down and goes up, or starts up and goes down, okay? So it's going to ultimately basically go in opposite directions, okay? And our end behavior here, as x approaches what over here? What is over here? Negative infinity, right? Where's our graph headed, y'all? Isn't it also headed towards negative infinity? So this has to say as x approaches negative infinity, our f of x or y approaches what? Negative infinity as well. Now, as we go to the right here with our x's, where's our graph headed as we go this way? It's headed up here. What's up here? Infinity, right? So infinity's over here as well, right? So as x approaches positive infinity, right, our f of x is also approaching positive infinity, okay? So, and you could just put infinity there as well. So now we're going to talk about some of this a little bit more here. So now, when we're talking about polynomial functions, we classify them by their degree, okay? So because they're classified by their degree, they have a distinctive shape. So, for example, this is 3x plus 1. And that means the slope is 3, and the degree is 1, right? Because there's actually a 1 there. This one is an x squared, and notice this could be minus 2, and if it was, this graph would move down to here, okay? Because it would be, where it's intersecting would be negative 2. This one is x to the third. It crosses how many times? 1, 2, 3. Now remember, if this graph moves up or down, then it might not. And this one has two curves, and that's why it's a third degree, okay? Because we add one more to it, right? Now this x to the fourth, notice again we got 1, 2, 3 times it turns, right? So again, it's going to be an x to the fourth. And it does cross how many times? 1, 2, 3, 4, okay? So that works sometimes, doesn't work every time, okay? So here again, we've got it crossing 1, 2, 3, 4, 5 times, right? But it also has 1, 2, 3, 4 turns, okay? And again, those terms, we're always going to add 1 to them to determine the degree, okay? So now we're going to talk about, let me erase this so we can actually talk through this. It won't be so confusing, okay? So we're going to talk about end behaviors now, okay? So as, when we have a leading coefficient that's positive, that's what this means when A is greater than 1. So when it's positive, as x approaches positive infinity, which is what this statement is, what's happening to our f of x or our y? It's also approaching positive infinity up here, right? Now, as we go towards what over here? Negative infinity. We're also headed towards negative infinity down here. Okay, do y'all see that? That's when we have an odd degree polynomial. When we have an even degree polynomial, so this one over here would have been like an x to the third, right? That's odd. And this one would be like an x to the second, okay? So this time, as we approach negative infinity here, we're approaching positive infinity there, right? And as we approach positive infinity over here, we're also approaching positive infinity. So the thing I like to keep in mind is when it's even, both ends are going to head the same way, but when it's odd, they're going to go in opposite directions. Okay, so now this one is negative. So when we have a negative leading coefficient and we're odd, notice it ends down over here and it starts up, okay? So this is just going to flip. So when we're going towards negative infinity, where are we headed? Towards positive infinity, right? And as we head towards positive infinity over here with our x, where are we headed? Towards negative infinity down here. Now, when it's even, again, remember, when it's even, your ends are going to either end up or end down, okay? So this could be an x to the fourth, for example, because that's even, right? So if it's an x to the fourth, then again, that's even, and it had a negative leading coefficient, because remember we have a negative leading coefficient right here, right? So that means this would actually have been like a negative x to the third, and this would have been like a negative x to the fourth, right? So it's ending down, okay? So that means as we head towards negative infinity, where are we headed here? Towards negative infinity, right? And as we head towards positive infinity, we're still headed towards negative infinity down here, okay? So the degree determines the shape. The sign of the leading coefficient determines the end behaviors. That's the key, okay? So now, we're going to look at some of these graphs. So let me show you how to get to this on Desmos. Now, we're going to go use this, we're going to click to go to Desmos.com and then click on the graphing calculator. Now, when you guys are in SchoolNet taking your midterm and other tests, this is what the Desmos is going to look like when you bring it up. Okay, so we're going to go ahead and put that equation in there that we just had. So negative x to the third minus 3x squared. And I'm just doing shift 6, y'all, to put it up there as an exponent, okay? And then plus 4x plus 5. Okay, so now we may have to zoom in or out to see everything here. So I'm actually zooming out here. So do y'all notice we've got some zeros here? There's a 0, there's a 0, there's a 0, right? So we can click on these. So if we want to see them, what they actually represent, you can actually click on them here. And notice we've got a minimum here, and we've got a maximum up here. And if we want to know also where it intersects the y-axis, we can click on that point as well. So now we have all of these points on here, and we can go back and look at this in our over to the right. You guys can see the screenshot that I took of the Desmos graph, okay? So now where are our zeros? Can you see them here? So we've got negative 3.7140, and then we've got negative 0.857, comma 0, and 1.571, comma, 0. Okay, those are the zeros of our function, so we would put those up here. So let's go ahead and do that now. And I don't necessarily have to put the zeros there, but you can if you want to. But this is going to be negative 3.714. That's this one right here. Then we've got the negative 0.857. And then we've got a third one, which is at 1.571, right? Okay, now let's talk about our minimums. So we have one minimum. You guys see it right here? Again, remember, when you're writing minimums, you have to give both the x and the y value. So our minimum here is negative 2.528, comma, negative 8.128. Okay, then we have a maximum as well. So this is our maximum, our high point of our graph, right? Okay, so this is going to be 0.528 and 6.128. Okay. Now the degree, we can get that from up here, right? So the degree of our polynomial is 3. The leading coefficient was negative. Y'all see that? So I'm going to put a minus here, or maybe I should just put negative, MEG. Okay. And then, was it odd or even? It was odd, right, y'all? So this is what we should know, even before looking at the graph, that the graph is going to either start up and end down, or start down and end up, okay? So as x approaches positive infinity, so as I head this way on my graph, y'all, where is this headed? Towards what? Yeah, towards negative infinity, okay? And as I head this way towards negative infinity, this is negative infinity here, right, y'all? Where's our graph headed here? It's headed towards positive infinity. Now, this is the way you guys got to think of this. When this is an odd degree and it's a negative leading coefficient, we're going to end down. So we're going to start up, okay? Remember, we're always going to go in opposite directions with our end behavior when it's an odd degree polynomial, okay? So here's our next one. So you guys go ahead and try this one, then come back to me when you're done. All right, so on this one, I'm going to go ahead and pull this off so we can see. Pause me and come back. There you go. There's our zeros are at negative 5 right here and 1, right? So those are our zeros right there. We've got a minimum down here of negative 2, comma, negative 9. And this time we don't have a maximum, right? So we can say none here because there was no maximum. The degree was what? 2, right? Our leading coefficient was positive. So I'm going to put a plus here, okay? Was it odd or even? It was even, right? So when it's even, remember, our end behaviors are going to go in the same direction. So this time as we're headed towards positive infinity here, that's what's out here, right? Positive infinity, y'all. Where's our graph headed? And as we're headed towards negative infinity, where's our graph headed? Isn't it infinity up here, y'all? So yes, both of these are going to go towards infinity. And anytime it's even, our end behaviors are going to end in the same, are going to go in the same direction. So go ahead and graph this one and then come back to me. All right, so again, if we're looking at our zeros, we've got them right here, negative 2, negative 1. We've got a 2, a 3, and a 4, okay? So let's go ahead and write those down. Negative 2, negative 1, and then I have a 1, a 2, and a 3. Now we're looking for our minimums. So we got one minimum down here. Y'all see that? So that's going to be at 0.281, comma, negative 50. Yes, negative 50. Sometimes it'll be that big. 791. And then our maximum, well, wait, we got another minimum right there. Y'all see that? There's another one right there. I missed it. So we have 2 minimums and 2 maximums. There's our other minimum. I'm going to go ahead and write that under here. That's going to be 3.619, comma, negative 9.91. Okay, then we have a couple maximums, okay? So I see them. So we have a maximum here, and then we have another maximum right there, don't we? And I'm not sure that that one got clicked on, y'all. Either 2 of the maximums did. All right, pause. Okay, so now also notice our maximums, okay? So I did snip this graph again. So we got a maximum here, right? And then we've got another maximum back over here, okay? So those were our maximums. So one of them's at, again, negative 1.582, comma, 22.288. And then we've got another one that is at 2.482, comma, 5.915, okay? So our degree, we know, is a what? This is fifth degree, right? Our leading coefficient was positive. I'm going to put a plus here, okay? Then, was this even, odd, or neither? So this was odd, right? So that's how we know that it's going to start one direction and end the other. And this one, notice it's starting down. So in other words, when it's starting down and it's ending up. Y'all see this up here? It's starting down and ending up. So what that means is we're going towards positive infinity over here. Where's the graph headed, y'all? It's headed towards positive infinity, right? So as x approaches positive infinity, f of x approaches positive infinity. And as x approaches over here, our negative infinity, where's our graph headed as we head this direction, y'all? It's headed towards negative infinity, right? So again, we knew these were going to be opposites. Because this is an odd degree polynomial, okay? All right, so here's our next one. Go ahead and try this one and come back to me when you finish. Now, let's talk about a couple things actually here before we move on. So if it says negative and it's x to the fourth, we know a couple things, right? So hopefully by now you know if this is even, okay, so we've got a fourth degree and our leading coefficient is negative, right? So, it's even, right? So that's even. So what does that tell me about my end behaviors, y'all? We can actually talk about our end behaviors right now, right? So our y is going to approach what? Both of these are going to approach negative infinity, okay? How do I know that? Because it's even and it's a negative leading coefficient. So this graph is going to start down and end down, okay? So now go ahead and let's see what this graph looks like. Okay, so this time we've got our zeros again. We've got a negative 3 right here. We've got a negative 1, we've got a 0, and we've got a 2. So we've got a negative 1, a 0, and a 2. There were 4 of them, right? And again, if we counted our terms, there are 3 terms. We add one more to it that tells us it's a fourth degree polynomial. So our minimum, we got one minimum right here. Y'all see it? That is at negative 0.5. Comma, negative 1.563. And then we've got 2 maximums. We've got one here and one here, okay? So, can't quite see that one over there on the right. Let me see if I can pull it over here a little bit. Yeah, there it is, okay. Sorry, y'all. So this one is going to be the negative 2.303, comma 9. And this one is going to be 1.303. 9. And isn't it interesting that the y value of both of those is the same? We're going to talk about that some more later, okay? All right, so now this is our example. And again, I know a couple things about this one. Because it's a fourth degree and the leading coefficient is negative, I know that this is going to end down, right? So I could actually answer this right now, even without seeing the graph, okay? It was even, right? So that's what's helping me to make this determination about our end behaviors, okay? So now let's go ahead and look at this graph. So, whoa, wait a minute. This is x to the fourth, but it just has one place where it crosses. Y'all notice that? Well, that's because these must appear there twice as answers, okay? So, just remember, something can be repeated, and if it's repeated, that's why this is an x to the fourth, and it would actually still have 2 zeros only, okay? So this is negative 1.225 and positive 1.225, okay? Our minimum, we don't have any, right? This has none for minimums, okay? And then our maximum here is going to be 0.6, okay? So here's what you guys need to keep in mind. That number that we've been talking about as far as the terms are concerned and the zeros of the function, those are maximum numbers, okay? So this one actually has less, and that is, I would guess, If we were to factor this, we would see that their factors here would be x plus 1.125 and x minus 1.221. Yeah. Anyway, these would appear twice, y'all, in our factors, okay? These two zeros of the function. All right, so go ahead and try this one, and then come back to me when you're done. So once again, this is a third degree. Leading coefficient is positive. So that means that it's odd, right? So that means that our end behaviors are going to, as we approach positive infinity, the graph's going to approach positive infinity, right? As the graph approaches negative infinity, the graph's going to approach negative infinity for our f of x, okay, or our y. So let's look and see if I'm right. Yeah. So as we go this way towards negative infinity, that's what I was just talking about, right? Where's the graph headed, Joe? Towards negative infinity down here, right? And as we head to the right, towards positive infinity over here, right? The graph is headed where? Positive infinity up here, okay? So here we go with our zeros. -3, -2, 1. They're not always going to be pretty, y'all. So don't expect them to be, but they are in this particular graph. Okay? And then we've got what? Do y'all see a max and a min? So this looks like my max right here. So this is -2.535 and 0.879. And then our minimum is right over here, right? That's our low point. So that's what a minimum is, okay? So that's -131, comma, and this is, sorry, I don't want to do that, -6.065, okay?